Hi, I'm Mr. V. Today's illustrative mathematics lesson is from Unit 1 on rigid transformations, the second half, and we're on Lesson 19, Evidence, Angles, and Proof. And the objective, by the end of the class, you should be able to say, I can label and make conjectures from diagrams, and I can prove vertical angles are congruent. That's what our objective is today. So the next four pages 3 through 6, deal with angles. You're supposed to find the missing angles and explain how you got them. So I'm going to show you what they are. Please pause this video if you haven't done this already. Try to do it on your own and then check your answers with mine. First, we have this setup. You'll notice we have a straight angle. A straight angle, which I'll write down the words because it's that important for you to remember here. A straight angle is a 180-degree angle. So if a person said, I have no clue how to do this, my first hint would be how many degrees are in a circle. And then the next thing is how many degrees are in a straight angle. A straight angle would be the measure of angle EAB. The middle letter is the vertex of the angle, and this is equal to 180. That's a straight angle. Well, this is also a straight angle. This is also 180 degrees. Together it makes 360. So if this whole angle is 180, the question then is how much is the angle DAE, this one. I'll put a tick there to distinguish it from this one. And the relationship is that these two angles have to add to 180. So, all right, they equal to 180. If this is angle X, we'll say X plus 50 is equal to 180. How do I get the X by itself? I'll do the inverse operation. Instead of adding, we'll subtract. Anything you do to the left side of the equation, we do to the right. That's the subtraction property of equality. We end up with 130 is equal to X. So this angle is equal to 130. Here we have an angle that is 30. How much is the angle? This is angle FEG. Angle IEH looks like it's also 30. How could you explain to me that it's 30 degrees? I'm going to show you two ways, and these ways will keep coming back to us during this lesson. First thing is if I rotated this angle 180 degrees around point E, I end up at the same place. Another way that I could do this, I'll show you three ways. Another way I could do this, if I take the angle bisector of angle IEF, I want to take the angle bisector. This cuts this into two equal parts. If I were to reflect across this angle bisector, that would get me to 30 degrees to the same place. And now comes a different way. I'm going to show you mathematically how I would do this. Mathematically, I'm going to label these. I've already got the points here, but instead of labeling it angle FEG, angle FEI, angle IEH, HEG, I'm going to label this angle A, B, C. And I could also call this angle D, but I'll just label these three. We'll notice that these two angles form a straight angle. That means that they add to 180. So A plus B is equal to 180. Here, we also have a straight angle. That means that C plus B is equal to 180. Since they both equal to 180, I can substitute this value in for this one. When I plug that in, I get A plus B is equal to C plus B. I have B on both sides of the equation. I can use the subtraction property of equality to subtract B from both sides because the negative B is equal to negative B. And I end up with A is equal to C. This is a proof of my conjecture that they're the same. You can see that they're the same. Some of you may have done something different still. So instead of doing this, you may have said, well, I've got the 1 degree is 30. So I know that these two angles make a 180. So this has to be 150. 150 plus 30 is equal to 180. Further, I know that these two angles have to equal to 180. Since this is 150, this has to be 30. So that's another way of doing it. Let's see, going down. I'm sorry. Where are we? go down to my next lesson here. For the general case of vertical angles, trying to prove this angle is congruent to this one. One is that we could rotate it around this point where they intersect 180 degrees. And I get to the same angle. So if this is angle A, this is angle A. The general case, if I have A, B, and C, when I know that A plus B is equal to 180, B plus C is equal to 180, if I substitute both of these into the equation, I get A plus B is equal to B plus C. Subtract B from both sides, I get A is equal to C. So this is doing it algebraically. This is doing it with a transformation. How much are the missing angles? Straight angle. These two angles add up to 180 because this is a straight angle. This is going to be a straight angle too. We call that supplementary. I'm writing this down for your benefit. I need you to write it down too. These two angles are also adjacent. So I could have two angles that are supplementary. That is like I could have a 60-degree angle and a 120-degree angle. If you add these two together, you're going to get to 180. They're supplementary, but they're not adjacent. These two are right next to each other. They're adjacent to form a line. And so this would be a straight angle, which is what we said before. And you may be used to acute angles between 0 and 90, to right angles, which are equal to 90, and to obtuse angles, which are between 90 and 180. If it's equal to 180, it's called a straight angle. This is 180 degrees. If it's more than 180, it's called a reflex angle. Now, we don't talk about reflex angles very much. But these adjacent supplementary angles, these two angles are what is called a linear pair. What do I mean, linear pair? Where do you think that word comes from? Linear. Oh, line. Makes a line. Adjacent, two angles that are adjacent and supplementary are a line. So what do you add to 65 to get to 180? Well, I could call this x. And I say x is equal to 180 plus 65 is equal to x. Subtract 65 from both sides, and I get 115 degrees. All that trouble for this one little problem. Here we have 135, vertical angles, 180-degree rotation. What do I add to 135 to get to 180? To get a linear pair, I'm going to add 45. And since this is a vertical angles, rotate it by 180 degrees, this is 45 as well. Questions or comments? So going on with our lesson, what do you notice? Wait a minute. What do you notice and what do you wonder? It can't be right, can it? So what do you notice? What do you wonder? Some comments from students. I'm going to anonymize them, and I will show you what some of them wrote. Some of them said, they're all different angles. All the dotted lines are 90-degree angles. Well, I wonder if that's true. That's a certainly good observation. They look like they're 90. There are 4 different lines, 3 different line setups. I don't count 4. I count 1, 2, 3, 4, 5. 1 line and 3 rays, but that's okay. Notice the lines are going in different directions. There are dotted lines all around the filled-in lines, except for this side, of course. So they're between them. That's interesting. All the dashed lines make a right angle. That's a conjecture. That's a good thing. I wonder why all 3 of the dashed angles make a right angle. I do too. I wonder if they make a right angle. The straight angle on the right is the farthest one away from the dashed angle. So this one here is the farthest away. I don't know if this one's maybe farther from this one, but this is farther away from the right side. And these dotted lines are farther away when you, no, they're not, are they this? I don't know. What does it say here? Anyway, these are different conjectures. You're able to use your powers of observation to make a conjecture, to make an educated guess. And when we do that, we come up with this statement. Here is a ray. I'm going to move my picture down so you can see this. Here is a line L and ray R. And the dashed lines are angle bisectors. You're used to seeing perpendicular bisectors, which is when I have a segment and I divide it into 2 equal parts, and this dotted line is doing the cutting. It's the bisector. This is what is being bisected, 2 equal parts at a 90-degree angle. This is a segment bisector. This is not a segment bisector. This is an angle bisector. It makes this angle here, where is it? This is the same as this one, and this one is the same as this one. I'll strike 2 arcs here for this side. So this is A, this is A, this is B, this is B. When you add them together, you get A plus B is equal to 180. That is, 2A plus 2B is equal to 180. And I get 2 of A plus B is equal to 180. So what is A plus B going to equal to? Anyway, Diego makes this assumption. He says, the angle formed between angle bisectors is always a right angle, no matter what the angle between R and L is. That's not very clear with the drawing that we had. Even with my markings of A and B on it, it's not very clear. So what I'd like you to do is to mark the drawing and label it. So we write symbols, we draw figures, we label the drawings, and we model real-world situations. So I'm interested in the language that you use to reword his conjecture. And then I'm going to show you. So if you try this, then I'll show you mine. I'll show you what I did, what I came up with. So here's the drawing. And you can label a line with a lowercase letter or array, like lowercase letter, lowercase cursive. You can also label them with capital block letters as points. So I'm going to mark this as point A and point B. So I have line AB instead of line L. And this ray, it's going to intersect here. I'm going to say it intersects, C is on line AB. And I'll label this CD, ray CD. If I were marking the symbol for it is like this. If I mark the line, I could say line AB, and I'm going to put arrowheads in both directions. Line AB, point C is on line AB, ray CD, and I'll put an arrowhead here and here too. Ray CD. And then I have an angle bisector. I need to name this though, and I'm going to call this one, I'll put a point E here. So this is ray CE, bisects angle BCD, and ray CF bisects angle DCB. Now the conjecture that I'm going to come up with is that with this setup, oh, and I should mark these angles too while I'm at it. I'm going to mark these. This is congruent because this is an angle bisector. This one here is the same as this one because this is an angle bisector. My conjecture is that this angle FCE, is going to be 90 degrees. That's what I'm conjecturing. We do a lot of exploration. After exploring something, we can come up with enough evidence to say, well, we'll make a conjecture. And then we will do a rigorous proof of this. So a rigorous proof of this one would be to say, for example, I have A, B, and B. I could say A plus B is going to make this a straight angle, so this is equal to 180. Now I have 2A plus 2B is equal to 180. And now I can say, well, 2 of the A plus B is equal to 180. So A plus B, if I divide both sides by 2, A plus B is equal to 90. This would be a rigorous proof to show that it works for all cases. And I used the general case. I did not use a specific degrees just to show that this works. Let's see. Vertical angles. Oh, before I go on, let me show one last thing. I have created this with Desmos. I actually made a Desmos of this. And you can see that I've drawn line AB, I've drawn ray CD, I've made the angle bisectors. If you were to measure this angle, it's the same as this one. And this is the same angle as this one. And it's dynamic. That means that we can use it, we can move it around instead of just being stuck in one place. So if I move this, you notice how the angle that's measured down there is 90 degrees. It stays as 90. Why do you think it would be 90? Well, if I'm taking half of the one angle and half of the other angle, that's going to be half of two angles that add up to all these angles that add up to 180, and half of that would be 90. So this works all the time. This is a visual proof of the same thing. Finally, let's see. Vertical angles are non-adjacent angles formed by intersecting lines. Here's the diagram. What is the relationship between them? Write down a conjecture and then prove it. So when we label this, you could label this. This will be the intersection point. We'll call it M. And I could label this A, put a little arrowhead on it, B, C, and D. And the question is, how can we prove that vertical angles are congruent? So how do we prove that angle AMD is congruent to angle BMC, or this angle is congruent to this one? One way of doing it is to rotate it 180 degrees around point M. A second way is to call this angle A, B, and C. We know that this is a straight angle, so A plus B is equal to 180. We know that this is a straight angle, so B plus C is equal to 180. And I could substitute this into here, or I could subtract these two equations. When I get this, I get A minus C is equal to 0. Add C to both sides of the equation. A is equal to C. This is another way of proving it algebraically, that these two vertical angles are congruent. This is a general proof. It's a rigorous proof. One reason that mathematicians like rigorous proofs, even when conjectures seem to be true, is that sometimes conjectures that seem to be true are not. They turn out not to be true. And this is a famous example. I'm going to go through it right now. If we draw n points on a circle and connect each pair of points, how many regions does that divide the circle into? So let's just do that. I have a GeoGebra applet that we can use to do this, and I have this table of values. Where is it? Right here. And so let me just erase this. I'll erase this as we go through it. Go down, down, erase it, down. So if I were to show you 1 point on the circle, 1 region. Oops. 2 points on the circle. 2 points on the circle, 1, 2. 2 regions. I need to go here. 2. 3 points on the circle. How many regions? 1, 2, 3, 4. Okay. This is interesting, isn't it? There's 4. What about 4 points on the circle? If we do 4 points on the circle, we have going up and down 1, 2, 3, 4, 5, 6, 7, 8. There's 8 regions. Oh, I'm noticing a pattern. I think I'm noticing a pattern. How about 5 regions? So we go 5. We have, I'm going to count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. Oops, 16. Would you like to make a conjecture as to how many you think there's going to be when we have 6 points on the circle and we combine them? So if I, oops, sorry. There we go. There's 6. I'm going to copy this over to my whiteboard. If I can find the picture, there it is. And I'm going to count these. I'm going to suggest that we think there might be 32 because we've done 2, 4, 6, 2, 4, 8, 16, 32 would be the next one. 1, 2, 3, 4, 5, 6. Do the other side. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Didn't I tell you it was going to break apart? I told you this is a conjecture that was a very famous one that doesn't, it turns out not to be true. It's not going to be 32. It's 30. So anyway, this is a statement that should make it into your table, your reference chart. If we were in brick and mortar, I would be checking your reference charts to make sure that you did this. Today's lesson, vertical angles are congruent. That's the big idea. These opposite angles are congruent. Not opposite, vertical pair are congruent. We used to call them opposite when I was a kid, but they stopped doing that because like if you have a square and you have opposite angles of a square, that's not the same as vertical angles. So we give it its own name. Don't ask me why they don't call it horizontal angles, but they're called vertical angles. In everyday life, it's complicated for us to understand the reasons why statements are true and false. For example, Think about the economic system, the international relations, history of a company. In geometry, the objects of study are not so complex. Angles, lines, points, triangles, and so on. So in this way, geometry is a great training ground for understanding the reasons why ideas are true and communicating those reasons to others. That's the proof. Today we came up with several different explanations for why vertical angles are congruent. Consider the following questions. What is the difference between the arguments based on angled measures and on transformations? Remember, we did the reflection. We also did a rotation of 180 degrees versus doing the 180. Which argument makes more sense to you? The rigid transformation that takes one of the vertical angles onto the other, or using a straight angle and saying it adds to 180 and this one adds to 180, so therefore, what is the difference between an angle and an angle measure? Ooh. Anyway, add this to your statement, and then we have a cool down. And I'm going to put this question on a test, so I should strongly urge you to figure out the right way to explain to me, or a good way to explain to me, why A is equal to C. And that's all I've got for today, folks. So good luck and success.